I would like you to see the craziest thing I've ever seen in my whole life. You ready to behold this? Voila! So what the hell does that mean? Well, the chances are if you understand it, you already know how it came about, and it's really cool. But the notation here is called summation notation, and what that means is it's the sum of natural numbers tends towards negative a 12th. Now, natural numbers are all whole numbers starting at 1 and going on. So 1, 2, 3, 4, 5, blah, blah, blah. But no fractions and no decimals of any kind. And so how does that work? 1 plus 2 plus 3 plus 4, well, geez, that's just 10 plus 5, that's 15 plus 6, that's 21. That's not right. How does it become a negative fraction? Well, I am going to tell you about that. But first, I'd like to tell you about how I stumbled upon it. You see, I told you before that I'm a physics and engineering major. And one day, before physics lab, I was sitting there, and I just picked up a textbook on M theory. Because I have no life. Because I am an engineering major. Engineering majors have no life. And I was skimming through it, like I was pretending, I knew what the hell I was talking about with M theory, string theory, a lot of people call it. It was over my head, but like early on, I just saw this, and I happened to understand what the symbols mean, and I called bullshit like right away, and I did some research, and I found like a way to evaluate it using zeta functions, or the zeta function, I should say. And that's beyond my experience. I don't know. So I was like, oh, I'm just going to curb that and learn about it when I get there. For now, I mean, I suppose I'll believe it. Maybe it's true in some weird vector space or something. I don't know. And so I curbed it for almost a year. And then I ran into it on a YouTube channel that I watch called Numberphile. And here's the link to them. They're rad if, you're into mathematical stuffs like I am. They've got a lot of pretty neat videos. But anyway, they had one on this, and they used a method of solving it, or proving it. Well, proving it is not the right word. Justifying it is much, much better. And it blew my mind. You don't need any heavy background in math, just basic algebra, and you can show that this is true. And that's how I'd like to do it now. So, to begin, we're going to need a blackboard of some description. Ooh, that's a good one. Let's fuzz it out, and it is a blackboard now. Okay. So to do this, we need to look at 3 different sums of series to be able to justify it. So you're going to have to bear with me a little bit. So let's look at the first one. We'll call it S1, right? It is the series of 1, minus 1, plus 1, minus 1, plus 1, etc., 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 forever. And I don't know which way to go. There he is. Come on, Motard. Go! Go! Hooligan. Alright, so the first one was S1, and that was 1 minus 1 plus 1 minus 1 plus 1 minus 1, etc., etc., etc. Alright? The next one... He is such a hooligan. The next one's going to be S2, and that's going to be 1 minus 2 plus 3 minus 4 plus 5 minus 6, etc., etc. And then finally the third one, the one we're after, the one we're trying to show, right, is going to be S3. And it's going to be 1 plus 2 plus 3 plus 4 plus 5 plus 6, etc., etc., etc. All right. Super. Now, what does S1 equal? That's what we have to show first, right? It seems like, well, this is either going to be 1 or 0, or 1 or 0, wherever it is you stop. However, because we're summing an infinite number of them, it's a little hairy. So, let's make an equation, because we math guys love equations. We'll start on the left-hand side, right? We're going to have 1 minus S1. So what does that equal? That equals 1 minus parentheses 1 minus 1 plus 1 minus 1 plus 1, etc., 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 in parentheses. Super. Now let's distribute that negative across the parentheses. So we've got now 1 minus 1 plus 1 minus 1 plus 1. Does that look familiar? That's right. That's the series we're after. S1. Right? So we now find that 1 minus S1 is equal to itself, is equal to S1. So, let's subtract S1 from both sides of this equation. Oh, I'm sorry, not subtract. Let's add S1 to both sides of this equation. So we get now 1 equals 2 times the value of S1. So let's divide by 2, right? And we now get that S1 equals a half. Success! That is the value. So 1 minus 1 plus 1 minus 1 plus 1 forever equals a half. That's actually very important, and that's a big freaking deal. Okay, so let's look at this next one, right? This S2. We have to figure out the value of S2, because we've got the value for S1, that's a half. So S2. Let's look at a combination here. Let's take, sum 1 and subtract from it the value of sum 2. So, S1 minus S2. And now what's that look on the other side of the equal sign? Well, it's going to be 1 minus 1 plus 1 minus 1 plus 1 minus 1, etc. Subtracted by parentheses 1 minus 2 plus 3 minus 4 plus 5 minus 6, etc., etc. And so let's do that, right? Distribute out that negative. So 1 minus 1 is 0, right? 1... let's see, it was 1 minus 2, so it's plus... Hang on a second. Okay. 1 minus 1 is 0. Okay, and so negative 1 plus 2, because we distributed that, is negative 1 plus 2 is positive 1. Let's look at the next one. Positive 1 minus 3. That's negative 2. Okay, let's look at the next one. Negative 1 plus 4. All right, that's positive 3. Now let's look at the next one. This will be the last one. So, let's see here. It was positive 1 minus 5. That's negative 4. All right. So we get that S1 minus S2 is equal to 1 minus 2 plus 3 minus 4 plus 5. Does that look familiar? That's right, that's S2 that we're looking at. Excuse me. So, S1 minus S2 equals S2. Again, the same type of situation, right? We're going to subtract add S2 to both sides, and we're going to get S1 equals 2S2. We're going to divide by 2 again, and we're going to see that 1/2 of S1 equals S2. Right, so what was the value of S1 that we found before? A half. So 1/2 times 1/2 is 1/4. We're nearly there, right? We now have that S1 equals a half, S2 equals a quarter. Now the last thing we need to do is find S3. Proceed when clear. It's clear. Looks like there was a slide. Alright, so much the same, right? With the last one we took, for the first one we did 1 minus S1, and the second one we did S1 minus S2. Well, this time we're going to do S2 minus S3. S3 is the one we're very, very much interested in. Okay, so now that means it's 1 minus 2 plus 3, minus 4, plus 5, minus 6, etc., etc., etc. Minus parenthesis 1 plus 2 plus 3 plus 4 plus 5 plus 6. Okay. Let's distribute that negative. So we have 1 minus 1 is 0. Negative 2 minus 2 is negative 4. 3 minus 3 is 0. Negative 4 minus 4 is negative 8. 5 minus 5 is 0. Negative 6 minus 6 is negative 12. And this keeps going on and on, right? You're seeing this pattern: 0, negative 4, 0, negative 8, 0, negative 12. Next one's going to be negative 16. Very good. And so we now have that S1 minus S3 is equal to negative 4, minus 8, minus 12, minus 16, etc., etc. Let's factor out a negative 4. All right? So we get S2 minus S3 is equal to negative 4 times 1 plus 2 plus 3 plus 4 plus etc., etc. What's that? That's S3. That's what we're looking for. Yes! So we've got S1 minus, or I'm sorry, not S1, S2 minus S3 is equal to negative 4 times S3. Super! Let's add S3 to both sides of this equation. So we get S1 equals negative 3 S3. Divide both sides by negative 3 to isolate S3. Therefore, S3 is equal to negative 1/3 times S2. And what did S2 equal? 1/4. Negative 1/3 times positive 1/4 is negative 1/12. Therefore, there it is. S3 is equal to negative 1/12. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus forever is negative 1/12. Huzzah! Blows my mind, and I absolutely love it. And I hope you enjoyed. I've enjoyed this ride. I've enjoyed talking about it. It's two of my favorite things: motorcycle riding and counterintuitive proofs, justifications, whatever, same thing. Anyway, signing off.